Council of Indian Society of Pulses Research and Development is pleased to honor by awarding Dr. Rajiv Vasne, Director General Dixit as Honorary Fellow of the Society. And this medal from INSA and Professor Vasne has been recognized as highly cited researcher by Thomas Reuters for last 5 years in a row, one of the 10 most influential Indian science by Times of India as leading Indian daily newspaper, and one of the 2000 Challenge Makers Society of India by Private University. He has received recognition for different awards.
Stuff, huh? And I need to put these things somewhere. Picture also. Wow. And I feel very humbled and honored to receive this Honorary Fellowship Award of this very prestigious society of Indian Society of Pulses Research and Development. I am grateful to President ISPRD and Director IIPR Dr NP Singh, Secretary ISPRD Dr Katiyar, and the Executive Council and membership of ISPRD for selecting for this honor. I should mention that although I have received several awards and honors, this is very special for me, as this is coming from the Society of Pulses Research and Development, and this is the area in which I have been working for last 14 years. I should also mention that this award has been possible because of the hard work and contribution of my present and past colleagues, including research staff and students from the Center of Excellence in Genomics and Systems Biology, Research Program Genetic Gains, ICRI-SAT, and all collaborators from ICAR institutes, including IIPR, IRI, State Agricultural Universities, and many other institutes of India, and from many other countries of Asia, Africa, North America, Europe, and Australia. I am very much pleased to see that many of them, they are here, and I see several of those colleagues and well-wishers on the dais, as well as off the dais, and I am receiving this award in this presence, so I feel really honored. So my heartfelt thanks to all of my colleagues and collaborators around the world. I should mention that I am very happy to receive this award when India is marching towards self-sufficiency in pulses. As we know that India produced about 25.23 million ton of pulses in the year 2017-18 and about 24.02 million ton in 2018-19, where we have a target of 32 million ton by the year 2030. And this has been possible because of the able and dynamic leadership of ICAR, especially Dr NP Singh, Director of IIPR, and also policymakers of Department of Agriculture and Cooperation from Delhi. I remember when Dr Mohapatra was presenting one award to IIPR in the last Krishi Mela, he mentioned that IIPR and its network programs, they have developed and released more than 700 high-yielding varieties, along with 50 matching package technology across the countries, and by strengthening the breeder seed program and quality seed by establishing 150 seeds hub in India, the country has reached near the self-sufficiency in the seed sector. And not only that, the import amount has also been reduced with the buffer stock of about 7.75 lakh ton now. So India is attaining stability in pulses production front. And for this excellent work, Dr NP Singh received the Sardar Patel Outstanding ICAR Institution Award 2017 for IIPR in March 2019. So let's congratulate Dr NP Singh and his team for this wonderful contribution. And ये Dr NP Singh साहब के लिए दलहन क्रांति जनक के नाम से फ्यूचर में उनके लिए. And not only that one, as I mentioned, so this has happened possibly because of the area expansion and also the productivity enhancement. In this context, I should also mention the other award which was bestowed to AICRP-Chickpea, and they were honored with the prestigious Chaudhary Devilal Outstanding All India Coordinator Research Project Award in 2016. And thanks and congratulations to Dr. Dixit for the current coordinator and also the former coordinator Dr. NP Singh. And of course, ISPRD has played important role. You all have played important role. So I think this is the time to congratulate everybody. So congratulate yourself and all the other leaders of India. So it's time to celebrate, but at the same time, not rest on the laurels. So let's talk that what is required now for future. We have not completed our job. We have completed one milestone, but our journey is still very far. Why? Because there are a lot of challenges. We know that there is an increased demand. If we would like to have the self-sufficiency in the proteins in the country, by 2030, we need to have 32 million ton pulses. And then only we can provide that or have the protein availability about 42 grams per capita per day. This is good news that area has increased, but we can now continue to expand this area further. So what we need to do, we need to expand, we need to increase the crop productivity. We have a lot of gap in the genetic gains and also the yield gap. So we need to work in this direction. There are a lot of challenges, including the climate change, etc. And many new diseases are coming now. Dry root rot, lesser nematodes in chickpea, phytophthora blight in pigeon pea, and many races are evolving. We have the issue of the herbicide susceptibility. We are talking about the quality seed production. We need to address the issue of the refinement in the crop management practices. So to address these issues, I think we have a lot of opportunities and we can do these things. There is a need for that embracing the new technological advances. Then only we can reach the targets for the 2020, which we had 26 million ton, and 2030, 32 million ton. And we can do this thing by adoption of the new advances in research for development of superior varieties, coupled with the refinement in the crop management practices. And this is the need of the hour. And Dr. NP Singh and I was together in Indore one day before, and where we also had very impressive speech from Dr. Mohapatra, the Director General of ICAR. And he highlighted several areas. So he mentioned especially for wheat, but then I was very impressed, and I would like to mention a few things in the pulses. When we are talking about the integration of new technology, there are many technology, and again, Dr. NP Singh has been a great friend, well-wisher. When he was the AICRP coordinator, at that time point, genomics scientists were not invited to the AICRP meeting. But Dr. NP Singh changed the scenario. He started to invite me in those meetings. We started to discuss with the different breeding community that how we can integrate these tools. That was the time that we did not have the markers, we did not have the genetic maps. But now, together with the partnership of ICAR, with many state agricultural universities, international partners, we were successful not to develop just genomic resources, but the genome sequence. This year, we have published a paper for 429 lines of chickpea genome sequence. India has contributed genome sequence of rice. However, they have not been able to even the resequence more germplasm collection, but we were able to do this thing in the case of chickpea. We have been able to do these things in the case of pigeon pea. So in some areas, we are moving ahead than the important crops in this country as well. So now, once you have the genome sequence, in several pulses we got, but in many other pulses we still don't have. So this is the time now we need to think about the genome sequence, assembling the genome sequencing on these crops. These include pea, lentil, black gram, etc. Second, when you are having the genomes, you have the genes in the hand. But these genes, they are not expressed at all the time in all the tissues. We need to understand their expression mechanism. We need to understand that what is happening in the genome. And not only that, nowadays there are the issues, or there are a lot of interesting phenomena of the epigenome, that what you see in the genome, what you see at the phenotyping level, they are entirely different. So what kind of other features are involved? Can we understand the genome? Can we understand the gene expression atlas, metabolome, phenome, etc.? We are talking about the hybrid breeding in pigeon pea. Do we have clue about the cytoplasmic male sterility in the pigeon pea hybrid breeding system? How we can expand this particular area? So there are some important area in this direction. Other area is the germplasm characterization. Dr. GP Dixit mentioned that more than 10,000 exosomes they are being conserved and characterized in different places. Now this is the time that we need to characterize them in the field. We need to characterize them at the genome level. Again, together with several partners who are sitting here and with IIPR, we have embarked this big project where we phenotype 3,000 chickpea lines for 3 different years. in the field conditions. And not only that, we completed the genome sequencing of 3,000 chickpea lines. So this is a big task, big achievement, but we did it together. Now we need to do, what we need to do, we need to identify the haplotypes. We need to use the approaches of artificial intelligence, that if we combine this haplotype with this haplotype, what kind of yield will be there. Now again, don't think these are the hypotheses. The similar kind of thing I was talking 10 years back. Some of you were there when I used to show the pictures of the cars and motorcycles and the cycles, that how you can achieve this path faster. This is going to happen now. And this is the areas that we need to move. As a breeders, as a genetic resource scientist, we need to develop the specialized population. Not only the recombinant inbred lines, we need to have the magic lines, nested association mapping population. If you don't have the genetic variations, create the genetic variation by developing the mutant population. Nowadays, those days were gone that you are still working on the SSR or microsatellite marker genotyping. What we need to do, we already have moved ahead. We can do the genotyping based on the SLP marker, sequencing based genotyping. If you got the good variation in a population, we can map the trait in just 2-3 months if you have the high quality phenotyping data. We need to talk about the molecularization of the breeding program, and I am very happy to see this time in the report what Dr. GP Dixit mentioned. They are having a separate paragraph that how the evaluation of the molecular breeding lines, drought tolerance introgression line, wind resistance introgression lines happen. This is the way that we need to integrate these things. But now this does not need to be as a part of some project. We need to make this thing as an integral part. We need to internalize these kind of technology, and that's the way that we need to move. Now we are having, some of you are already working with ICAR-BMGA project where they are doing the digitization, they are utilizing the modern science technology. As a breeders, we have done wonderful work, but we can do further. We need to spend a lot of time in selection of the parents. We need to use all possible information of the genotype, phenotype. We need to keep on bringing the new parents in these populations, not just continuing with the same parental lines. We need to enhance the population size. We need to enhance the selection intensity if we would like to accelerate the genetic gain. We need to think more about the continuous population improvement, not just 1 or 2 lines. So this is the way we need to work. We need to have the intelligent experimental design, replicated testing, multi-location data, data recording, data analysis with the proper tools and the databases, etc. We need to think about the implementation of the early generation screening with the markers. Otherwise, we can continue to have several lines and then we spend the money on each generation. But now with the help of diagnostic marker, you can throw several lines even at the early stages. So these are several tools and technology. I was again happy to see that now this ACRIP group, they are talking about the genomic selection. We have developed these products by selecting 1 or 2 gene loci. Now this is the first time that you can select the better line based on the screening the whole genome. And this is possible. We have the tools, we have the infrastructure, we have the expertise. Now we need to bring these things together. And I think we can do it. We need to integrate speed building approaches, rapid generation advances. I know in chickpea some people do the 3 to 4 generation per annum. Can we make it as regular? Can we bring it to the industrial level? That for each time we will be having 6 generations per annum. Then we can accelerate the genetic gain. Now, another thing is that we are many times just scoring the phenotyping data, keeping in our files or putting on the computer. What we need to do, we need to start using these data. Use centralized services for the marker, genotyping, etc. If you will start to do these things in your lab, probably this will be very expensive. Still, we have the issues of the heat, drought, etc. What we need to do, we need to have the really phenotyping of large scale germplasm collection, population, and the target population, environment, etc. We need to dissect these complex traits like yield under drought and heat stresses, go to the component traits, identify the haplotypes of these component traits, use the new approaches to bring them together. We are still having the issue of the biotic stresses. Helicorpa is one of the major constraints. Now, if we cannot address this thing by conventional breeding or genomics breeding, we need to use the genetic engineering technology. I know that Dr. NP Singh, he has been wonderful biotechnologist for several years. They developed several important lines, but still in the country we don't have the favorable environment. We need to work with the policymakers that how to bring these lines in the field. This is good that from the biotechnology, at least genomics products are moving. Now we need to bring this genetic modified product. Now the approach is genome editing. But for genome editing, we need to identify the real genes which are involved for these traits. We need to think about the quality improvement. This is good that we are having the high protein, 20% or so, but now several lines show that you are having up to 30% protein content. Can you break this linkage drag between the yield and protein? Yes, we can. So we need to talk this kind of approaches. Again, even if you are having these high quality varieties, but if they do not reach to the farmers, our job is incomplete. So we need to strengthen this seed delivery system, and seed hub, this was one of the important approach, but we need to work in this direction. We need to think about the faster varietal replacement rate in the farmer's field. When I go to the different states, and this year I visited 4 different states, when I can talk to farmers, they are still growing the old varieties. We need to change that one. We should plan something that no farmer should be growing a variety which is more than 3 to 4 or 5, maximum 5-year-old. We need to work in this direction. We need to talk about this better agronomic practices, develop and fine-tune of agronomic practices, focused attention on integrated nutrients and water managements. Lastly, we should also think about the markets, that if we will just keep on talking about the produce, and if they are not connected to the markets, farmers next year, they will not going to grow this chickpea. This was the issue, that for instance, pulses production attained its peak about 90.25 million ton in 2013-14, but this could not be maintained in successive years because of the low scale price of pulses in the Indian market. Then hostile weather and low scale price at farmers' doorsteps led in drop of pulses production to 17 million ton in 14-15 and further 16.35 million ton. Policies interventions is very much required, and government of India recognized this thing, and then when they have sense, they realize this thing, they change some policies for promotion of pulses production, etc. And then with all these efforts, pulses production jumped 23.13 million ton in 2016-17, and then 2 million tons were added further in 17-18. So policies are also very important. As a scientist, we cannot do much, but we need to work with the policy maker. Dr Jha is here, and we always keep on interacting with the Department of Agriculture and Cooperation. In the end, I will say that India has already witnessed quantum leap in pulses production, and I am sure that ISPRD, IIPR and AICRP-Chickpea together with its partner institute from India and CGR centers will continue to work on above mentioned areas. And I am also very happy to come to this university, and they are doing great work in these different pulses. I was very impressed to see this work, that what you are doing, the university is doing. Once again, I am thankful to ISPRD and especially Dr NP Singh for this honor and recognition. And at this stage, I would like to thank several colleagues present in past leadership of ICRISAT as well as ICAR for all their support and best wishes and guidance, blessings to me. This list includes many colleagues, and I will request you to bear with me because these names are very important for me. So in this list, I would like to include the Director General, ICAR Dr Mohapatra, DG ICRISAT Dr Peter Carvery, DDG Crop Science ICAR Dr AK Singh, DDG Research Dr Karan Sharma from ICRISAT, and also would like to thank Dr William Dar, Dr David Worvingsons, former Director Generals of ICRISAT, Dr CLL Gowda, former DDG of Research at ICRISAT, Dr Ayyappan, Dr Mangla Rai, former DGs of ICAR, Dr Shopan Datta, Dr J. Sandhu, former DDGs Crop Science of ICAR, also Dr Mashood Ali, former Director of IIPR, once again Dr NP Singh, Dr GP Dixit, Dr IP Singh, AICRP-Chickpea Coordinator, and Dr SK Jha, former Head of the Crop Improvement of IIPR. I have been interacting with all these colleagues for last 10 to 15 years. And I would also like to thank former secretaries Sri PK Vasuzar, Sri Ashish Bhogna Sahab, Dr Patnaik Sahab, and now Sri Sanjay Agrawal Sahab. In the same series, I would like to recognize the contribution of some key colleagues from ICRISAT. Here, Dr Puran Gaur is already here, Dr KV Saxena, Dr Nigam, Dr Hari Upadhyay, Dr Vincent Wadage, Dr Krishnamurthy. They left ICRISAT, but I feel a gratitude and for all their contribution and collaboration. And of course, my team members, Mahinder, Manish, Rokiwal, Rachit, Manish Pandey, Abhishek, Hema, Anu, Lekha, Prasad, Vikas Pallavi, and many others. They have played an important role. And without their support, without their contribution, I wouldn't have received this award. So once again, I would like to thank to all of you, and especially our Dalhan Kranti Janak Dr NP Singh for this honor. So thank you very much, sir, and thank you very much.